Okay, so we have 4 minutes, още 4 минути. Може би колегите нямат още готовност с другата презентация. Okay, hello.
Hello, can you hear me?
Yes, we can hear you perfectly, so welcome.
Thank you.
And just to present you to the audience, this is a Thermo Fisher scientific presentation for ion torrent Gen exosystem, the first automated next generation sequencing solution for mild profiling. So I hope this will be very interesting for the participants of the current conference. So please, we are ready to hear you talk.
I will check that everybody can see my screen clearly and hear me clearly.
Okay, we can see you, and now we are waiting for the present. Yes, we can see the presentation as well now.
Great. Hello, thank you very much for having me here to speak today. I am Caitlin Gilmore from Thermo Fisher Scientific, and I'm the Regional Market Development Manager for Hematology Sequencing, which gives me the privilege to speak about our new myeloid genomic profiling solutions. If you're familiar with Thermo Fisher Scientific, you probably know that we've been one of the leading innovators in targeted next generation sequencing over the last 8 years. You may be familiar with our personal genome machine, which has been around for a long time, which uses this semiconduction form of sequencing where when a hydrogen ion is incorporated into a nucleotide, when a nucleotide is incorporated into DNA, the release of that ion is detected like a giant pH meter. And this has allowed us to develop these fantastic technologies that have been embraced and used in clinical laboratories across the globe. At the heart of our technology, we also have the ion AmpliSeq technology, which is our amplicon-based system of amplifying the target regions of interest for any particular application. So I think we're renowned for being simple, fast, and scalable, and supported. So this is the key phrases that we've really tried to live up to over the past years of development. And this has been incorporated into our newer sequences like the Ion Gene Studio series, which is coupled with the Ion Chef system, which allows the preparation of those libraries from samples for lots of different applications. And we have dedicated software, which is the Ion Reporter software, which takes that information from the sequencing and interprets the mutations that are present. But there are still lots of barriers and challenges for molecular pathology laboratories, both in hemato-oncology and solid tumor type applications, that often in those laboratories, next generation sequencing is considered to be too slow for some of the required biomarkers, and it can often require days and weeks to get to results. It's by many people considered quite complex, so rather than other sequencing methods where you're just looking at single targets, next generation sequencing is obviously looking at many different targets at once, and the analysis of that data can sometimes be considered too complex by many laboratories. Also, because of that complexity and because of the assays that come together with those systems, it can be considered too costly in terms of staff time and the reagents itself. And also too limited in terms of the amount of material. So one of the challenges in many pathology labs is that the samples that are taken only generate low and small amounts of DNA and RNA. And so in many cases, for many of the next generation sequencing technology, the material is too limited, that they don't have micrograms and micrograms of RNA to prepare certain types of libraries for analysis. At Thermo Fisher, they've listened to the clinical laboratories for many years and have tried to develop and adapt our technologies to have a system that really is valuable and useful for those laboratories. And I don't know if you have seen these adverts over the last year, but in December 2019, we introduced our new next generation sequencer, and we had this image going around the world, which was a new world of next generation sequencing. So this is the Ion Torrent Genexus system, and I don't want to give too much technical detail because I don't have that much time today to cover the system in great detail. But this system is considered the world's first turnkey automated next generation sequencing system. When it's used with the purification system, which is this little box here, and this box here is the main sequencing and library prep instrument. When these two instruments are used together, you can actually generate next generation sequencing results in a single day. That's within 24 hours. And so this is highly beneficial to many pathology type labs and clinical labs where they might need to provide an immunohistochemistry result quite quickly, and before, when they had to wait for the next generation sequencing result to accompany that, they no longer have to do that. That can be now combined into a single day and produced at the same time. It's automated from sample purification right through the library preparation and sequencing, and then with the integrated bioinformatics software, you can produce annotated results for all the mutations that are detected in a sample. And when combined together, this automation requires only 2 user touch points. That is, putting the sample into the purification system and then moving the sample from the purification system into the other system where the library preparation and sequencing and analysis is performed. There's also flexibility in the system that you can run one sample and up to 32 samples at a time, but you don't have to wait for the batching. So I'll show you a picture of how the chip inside the instrument works, but it means you can run different parts of a chip over a number of days. The system and consumables are all manufactured in facilities that are registered with FDA and relevant ISO standard certifications. And at the moment, the research applications that can be performed on the instrument include oncology and inherited disease research. And we've got reproductive health applications coming, and also further infectious disease applications coming. So I just wanted to compare it really to a typical next generation sequencing workflow of some other available and flavour of sequencing instruments that are out there. So not to be biased here, we have our own Gene Studio S5, which is the most recent sequencing instrument that was available before the Genexus. And you can see with purification of the nucleic acid out of a sample and quantitation of that sample to see the number of nucleotide, the number of nanograms of material that you get. This would usually take 1 day with our instrumentation. Day 2 and 3 would be concerned with the actual library preparation and then the sequencing of those targeted libraries. And then combined with the analysis and variant interpretation, you would usually be getting to a report generation on about day 4. And to compare that to an Illumina benchtop sequencer like a MiSeq, that is shorter because that can take up to 7 days with these different steps that are required. And then the QIAGEN gene reader there, another benchtop sequencer of around the similar size, we're up to 6 days there to generation of the results. But to highlight the features and benefits of the Genexus system, the purification system can purify nucleic acids, that's RNA and DNA from a range of different sample sources. So formalin fixed paraffin embedded material from solid tumor type samples, pure tissue, bone marrow, whole blood, urine, saliva, and peripheral blood lysates, all can be extracted in the purification system. I would just like to highlight that the purification system will be available next year. Currently, you can pre-put in your interest in that instrument, but that will be available to be coupled with the Genexus system next year. But that purification in that instrument only takes around 2 hours, and you can sequentially extract DNA and RNA in that system. The Genexus sequencing system here works in a similar way to our previous systems, that we have a chip where the sequencing takes place in tiny wells on this chip. But unlike our previous sequences, this is now divided into lanes, which gives you flexibility for sample batching and sample numbers, that you don't have to run all the sequencing capacity at once. You can split that up over 4 lanes, and they can be run on different days. And the reagents that you put in, the sequencing reagents and the library reagents and everything that goes into the sequencer, they have a stability of 2 weeks. So as long as that chip is, the full sequencing capacity is used within 2 weeks, you have that time to use up the reagents on the instrument. So it makes it very, very flexible. And for each of those lanes, a single lane can be run in 14 hours. And the full chip can be run and generate sequencing within 24 to 30 hours, depending on the length of the sequence application that you're using. And this can be run with 32 samples per run. So you could have 8 samples on each lane, for example, depending on the capacity of your laboratory and the speed at which samples come in. Coupled with all our sequencers, we have a number of targeted assays which have this ion ampliseq technology at their heart. This is the ability to amplify the regions that are really of interest in whichever research application you use. But for our oncology research customers, we have a family of assays which are trademarked as Oncomine assays. And these are different to some of our customizable assays in that they have enhanced manufacturing, quality control checks. All the protocols are tested with clinical research samples to ensure that they're working well with those types of samples. They have dedicated oncology research informatics systems integrated, and they always come with specialized implementation support. And what I mean by that are the people that come and help in the laboratories that choose to use these assays. So this can be our field application specialists and also our clinical application consultants, which can come and guide you through the analytical validation process of those assays to ensure you're understanding and interpreting the data and getting the best out of the instrumentation. Now, I just wanted to focus on hemato-oncology research because this is something that's really important to me. So my background is from clinical hemato-oncology myself. So before joining Thermo Fisher, I worked in hemato-oncology environment within the laboratory, actually interpreting results from samples. So this is something that's a passion of mine, and it's really great to be in a company that is dedicated and focused on trying to increase the portfolio for the applications in hematological malignancies. So if you'll be more familiar with these than myself, but these disorders are usually split into myeloid disorders and lymphoid disorders, depending on what their cell of origin is in the hematopoietic processes. But we have assays that cover all these different diseases at the moment. So just to look here at our myeloid assays, which I'm going to focus on for the last 15 minutes of the presentation, we have the Oncomine Myeloid Research Assay, which is available on the Gene Studio instrument and has been one of the really great sellers across Europe, Middle East and Africa. It's been a highly utilised assay on that system, and we're hoping that the myeloid assay on the Genexus system is going to be as useful to these laboratories and also it's a really well-suited application to this fast type of next-generation sequencing that the Genexus is capable of, and I'll cover that in a little bit more detail. We do have other assays currently available in our hematology portfolio, but these at the moment are for use on the Gene Studio sequencer, but these will be moving on to the Genexus. As I say, we've got a real focus and dedication to the hemato-oncology sequencing space. So for lymphoid assays, we have B-cell receptor sequencing assays and T-cell receptor sequencing assays. And I know that I'm speaking to an audience here that is heavily involved in immunology research. So although I'm talking about applications in blood cancers, these were equally as valuable for repertoire sequencing for T-cell receptor, although it would probably be the long read assay that we would recommend for that. We also have assays called the Iron Torrent Oncomine Childhood Research assay, which again is on the Gene Studio, which covers a lot of the childhood leukemia targets that are important. So I'm going to move on now to just giving you some more information about this myeloid genomic profiling on the Genexus system. So this is the Oncomine Myeloid GX assay. The reason the Genexus system and this particular assay is really relevant in myeloid profiling is because there are many different types of biomarkers, and I think historically in many of these molecular labs, these different targets have been analysed using lots of different methodologies. So we've just got some example there of some key targets that are important in risk stratification in acute myeloid leukemia as an example. And these are often sequenced by using standard traditional Sanger sequencing or sometimes just PCR amplification assays. In some cases, targets like fusion targets are detected using quantitative PCR. And in lots of laboratories where they've realized that there are more and more targets that are coming and they need to have multi-gene tests, they often outsource their samples for next generation sequencing external to the laboratory. What this means is for samples such as an acute myeloid leukemia sample, it can take 3 or 4 weeks to get all the test results together at the same time. And this can be through a laborious process, can be time consuming, often inefficient, taking a lot of lab staff time. And some labs also feel that they lose control of their samples by outsourcing to external laboratories to do their next generation sequencing. So this Oncomine myeloid assay on the Genexus system really fits well into this space because it's a simplified workflow and incredibly fast. You can complete the profiling of over 40 DNA targets and 29 RNA fusion targets, over 600 isoforms in a short period of time. And the analysis can then take all that information and link it to labels, drug trials and guidelines. So this is just highlighting the relevance and the key points that having a one-day turnaround time can be highly relevant in myeloid samples because there are now drugs available that they need to be used quite quickly and within 24 hours, depending on the circumstances. And so having this fast turnaround time is incredibly valuable in these research labs. Being able to simultaneously profile DNA and RNA is really of great use because there are known RNA fusions that are relevant for risk stratification and known DNA mutations. So the assay can be used with all the common specimen types that will be seen in myeloid research. So that's whole blood, peripheral blood lymphocytes and bone marrow. It's got this fully automated workflow which fits really well into a kind of clinical research setting, and it generates a fully annotated variant report. Just wanted to focus a moment on some of the targets of the panel. So the targets offer comprehensive coverage of all the relevant myeloid mutations, covering a range of myeloid disorders from acute myeloid leukemia, some of the myelodysplastic syndrome, myeloproliferative neoplasms, as well as chronic myeloid leukemia targets. And there's a few other examples there. For some of those targets, as I say, it's highly relevant to get fast results for those biomarkers. And there's a few examples here of biomarkers that we know we get feedback from clinical research labs that these are the ones that are of high value quickly. And being able to interrogate these RNA fusions and DNA simultaneously is of great value to them. The other thing that this system and this assay offers is the ability to detect FLT3 internal tandem duplications. Now, notoriously for next generation sequencing, these can be really problematic because they contain repeats within the DNA, which a lot of type of sequencing technologies can find difficult. And we have dedicated software that can identify these FLT3 ITDs within the sequence. And then all of these targets taken together can be linked to the biomarkers and relevant evidence from public data sources and compiled into a report. And I will show you an example of a report. So how does the assay look on the instrument itself? The assay runs 8 samples on a lane, and I think I've already described how you can run the lanes separately on the instrument. So for an example here, you could run on day 1 8 samples, day 2 another 8 samples, day 3 8 samples. So over 4 days you could run 32 samples. And when I say sample, I mean the RNA and DNA mutations in that single sample simultaneously. The assay kit comes with enough reagents to analyze 32 complete samples. So this is RNA and DNA in those complete samples. And that can be run over 2 weeks because of the stability of the reagents on the instrument. Once a chip is loaded and the reagents are loaded, you can, over those 2 weeks, run two lanes on day 1 and day 2, and then the next week you could run lane 3 and lane 4. So it really offers flexibility, and you don't have to run all 8 samples. It works out more economically viable to run 4 samples at a time because the cartridges within the system are all based on 4s. But you can see it's all cartridge based, and literally it's a plug and play system. You open the lid, put each of those reagents in, and we've timed. People who have never used the system can load that system in 1.5 to 2 minutes. It's very, very quick, and all color coded inside the instrument so that everything can be loaded simply, taking away the complex nature of NGS and staff training. And the other thing to point out, if anybody here in the audience is a user of the Gene Studio, you will know that some of our reagents are some of the cartridges in that system are quite large and take up a lot of space. These strips are very, very small, taking up a tiny footprint in the laboratory storage spaces, which is something else that we heard from customers has been really valuable to them. So I'm going to just cover some of the key targets in a little bit more detail, but you don't have to take in every target. These slides will be left, I'm sure, that for you to access so that you can have a look in more detail. And I will give you a website address at the end where you can go and look in more detail at these things. But you can see there's got 40 DNA gene targets, and these include full gene sequencing, 17, and then 23 hotspots. And then we've got these RNA fusion drivers, which we know are clinically relevant from research. and there are over 600 fusion isotypes and different pairings that can be detected by the assay. And I won't go into too much technical detail about exactly how that works. I'm sure some of you will know, but for some of you it will be new. This is the kind of thing that if you wanted to hear more, it could be further details can be discussed. The assay as well includes 5 genes that their expression levels are known to be relevant, and then there are expression control genes within the system as well to ensure that all samples are performing as expected as an extra quality check. So these are the key genes that are included at the DNA level here on this side. So these are the DNA hotspots and full genes, and then we have the fusion drivers and expression control and controls here as well. And just to give you a little bit more information on the RNA fusions, they are 5' drivers and the number of isoforms that are in the 5' driver, which we know that is very important in myeloid, and the 3' drivers and the number of isoforms in each one. So the Genexus software, as I outlined before, it does everything. It does variant calling and then the first level of annotation within the iron reporter system on the integrated sequencing unit. If you use Oncomine Reporter, our secondary software, you can take the variants that are generated and add an extra layer of information on there. You can see here some acute myeloid leukemia findings, and it can give you information on those biomarkers and further annotations from various public sources. I didn't have time today to go through lots of verification and validation data. I thought it was more relevant in the short space of time just to give you the key highlights of the system and the assay. But I just wanted to summarize some of the performance data. So these assays are all highly verified and validated within our internal laboratories. And some of the key criteria here, I just wanted to say that even with the flexibility of the different multiplexing that's available, we've been able to demonstrate high average coverage and depth of sequencing across the targets in the instrument and workflow. We've got excellent uniformity, and uniformity is just one of the key performance criteria that is often used in target sequencing to say that you get the same number of sequences and reads generated across the different targets. And we've been able to show this to be above 95% in blood and bone marrow samples. The level of and ability of detection is very sensitive, with single nucleotide variants being able to be detected to at least 5%. And then indel variants, some of these larger insertions and deletions, down to 10% and lower in many cases. And again, I highlighted the dedicated software for looking at internal tandem duplications, which are these targets of the FLT3 inhibitor drugs. And these can be detected at various sizes and frequencies in blood and bone marrow and many different control samples that we've been able to use. And I think it was the concordance was 100% with other technologies within the data. We've also been able to demonstrate the detection of key fusions to a low level in blood and bone marrow, and also robust expression correlation with qPCR for the 5 expression genes that are present on the panel. I'm going to leave it there because that's me at my 25 minutes, and just say thank you for your attention. I know it's much harder to concentrate when we're all in this new virtual world, but I'm leaving you with that website there, which is the www.oncomine.com/myeloid. Please go and look, all the information is there, and there's some key opinion leaders talking about the assay and the value of the assay, and there's a webinar there with some clinical data from a research group that you can register for and see more information. So thank you. I will take any questions as well. I think I have a couple of minutes maybe.
Okay, thank you for this really very valuable presentation, adding these new steps, new technologies in the area of NGS sequencing, and of course I'm sure that this will improve and fasten the diagnosis, personalized diagnosis of patients with hematological diseases, and in detail for mild oncological diseases. So thank you so much, and now I would like to thank also for this sponsorship of Anticell to our conference, and for that they're always one step ahead in order to meet the requirements of the current diagnostic facilities and practice, the current medicine. Please, do you have some questions to our speaker? So in the audience, no, but unfortunately we cannot receive questions from the participants which are online, but I'm sure that the communication will continue, and also discussion in other ways outside this room. Thank you so much.